Alonso, Maria, and Sierra were floating in inner tubes down a river, enjoying their day. Alonso noticed that sometimes the water was much deeper in some places than in others. Maria noticed there were times they seemed to be moving faster than at other times. Sierra laughed and said, "Math is everywhere." To learn more about the river, Alonso and Maria collected data throughout the trip. Here is Alonso's data table about the depth of the water as they floated along. Question 1. Use the data that Alonso collected in the table to interpret the key features of this relationship. Okay. In order to help us visualize this table, let's put a little graph here. Okay, so we've got over here the depth of the water increases, and then it goes down, and then it increases, and then it decreases. So let's start with some couple of basic questions. Start with maybe domain. Domain is all of our x values, all of our inputs, all of our numbers from left to right. And it looks like this particular domain goes from 0 to 120. So I'm going to write it like this. I'm going to write 0, 120. I'm going to put some brackets here on the side. Now let's do range. Range is all of our y values. It's all of our outputs. It's all of the numbers going up and down. My smallest number looks like 4, and my biggest number looks like 12. So my range is going to be from 4 to 12. Okay, but there's a catch here. This data in the table, right now it's discrete because we've got all of these like separate points here. But if you look at the graph, it is a continuous function because at any moment in time, there is a depth of the water. And we're not 100% sure that this table is complete. There could be places where the depth is greater than 12 or less than 4 because they weren't collecting it at every single moment along the journey. They were only collecting it at specific points. So the table is going to give us a pretty good picture, but you can't rely on it as being 100% accurate, at least not in this situation. So we're going to put a little star here. Okay, now let's talk about the parts where the graph is increasing. So this graph is going up. Oh, that's probably too thick. Let's try this. The graph is increasing starting here at 4, and it goes up to 10. But if I think about the x values that are associated with it, it's from 0 to 30. Okay, so if I go over here, I'm going to put increasing. I guess I'll do it over here. From 0 to 30. Now, the 0 is included, and it's increasing up to 30, but it's not really increasing at 30. So I'm going to put a little parentheses right there. Now, this actually isn't the only place where the graph's increasing. There's another place as well. Here from 60 to 90, this whole part right here is also increasing. So I'm going to add on to this 60 to 90. And again, we're going to put those parentheses there. Now, one of the ways that I can show both of these together at the same time is using this symbol. It looks like a U. This is U for union. Put a little note here. This is union. And it's kind of just saying like both of these together are the parts where it's increasing. Okay, now let's talk about where it's decreasing. Decreasing would be, let's go back to our highlighter here. There's a part where it's decreasing here, and that's from 30 to 60. We're going to grab that 30 to 60 here. And there's also another part where it's decreasing over here from 90 to 120. I'm going to put 90 to 120. Now, since 120 is our stopping point, we're going to put the bracket here, but the parentheses here. And I'm going to put this U for union again to show that there's this section and this section that are both decreasing. Okay, now let's talk intercepts. Let's see, x-intercepts. Doesn't look like there are any x-intercepts, no zeros there. Y-intercept, I'll use another color just for fun. Y-intercept looks like it's right here at 0, 4. Okay, let's see, what else can we say? We can also probably talk about maximum and minimum. So let's see, maximum would be, let's see, what was our biggest number? Our biggest number was at 12, and that happened at 90 minutes. So we can say 12 feet deep at 90 minutes. And then we also have something called a relative maximum, which, like this part right here, this is the max because it's the biggest point on the graph. But there's also this same kind of structure over here. This we're going to call a relative maximum because it's the tallest point, it's the highest point compared to the points around it. Like it's clearly a peak, but it's just not the tallest peak. So we have another relative maximum at, what was that, 3010. So there's another one right here. I'm going to put relative max 10 feet at 30 minutes. Okay. Let's see, if we have maximum and relative maximum, we should also have minimum and relative minimum. So let's do a minimum. I think our minimum was right. Oh, here's our minimum here. That happens in a couple of different places, actually. That happens here and here. So our minimum is 4 feet at 0 and 60 minutes. That's a 4 there and there. And then our relative minimum, there's another one over here at 120 minutes. It gets down to 5 feet. Okay, let's see, what else can we talk about? We can also say whether it's discrete or continuous. Because we're talking about the depth of the river over time, there's always, a depth. So this is going to be a continuous function. Okay, let's see. Can we say anything else? I think that's about it. All right, so we got domain, range, increasing, intervals of increase and decrease, intercepts, maximums and relative maximums, minimums and relative minimums, and whether it's a discrete or continuous function.